Good morning, afternoon, or evening. How y'all doing today? Welcome back to Morrow's Math Corner. Today we're going to learn how to work with linear functions and models in the real world. So let's get right to it. Remember that a linear function is a function of the form f of x equals mx plus b. Please remember that f of x is just a fancy way of writing y. So if you remember y equals mx plus b, you're already ahead of the game because y and f of x are interchangeable. Where m and b are real numbers, the graph of a linear function is called a line whose slope is m and y-intercept is b. Let's also remember that in order to find the zero, or in other words, the solution of any function, you have to find the x value when y or f of x is 0. Therefore, in order to find a 0, simply set the y or f of x equal to 0 and solve for x. The x value when y or f of x equals 0 is the 0 of the function. So let's go ahead and find the 0 of the following function. F of x equals negative 5x plus 15. In order to find the 0, we're going to go ahead and set the f of x or y equal to 0 and solve for x. We're going to go ahead and subtract 15 to both sides. And then we're going to go ahead and divide that negative 5x that's being multiplied to x to both sides. And x equals 3. So my 0 of this function is x equals 3. If I wanted to write it in x-intercept form, though, I would write it as 3, 0. Because yes, just in case you were curious, a 0, a solution, and an x-intercept are all the same thing. It's just a matter of how you go ahead and write it. Zeros are written as just the value of x, and x-intercepts are written as ordered pairs. All right, let's have a little review of how to graph a linear function. First thing you want to do is go ahead and find and plot the y-intercept or b. Next step is to follow the slope both forwards and backwards for 3 to 5 points. Please remember that you always run to the right unless going backwards. All right, so for our first graph here, A, we're going to go ahead and graph it in red. So the first thing we're going to do is we're going to find our y-intercept, which is negative 5. So we go down 1, 2, 3, 4, 5. And my slope is 2. Remember that there's an invisible 1 underneath that. So I'm going to rise 1, 2, and I'm going to run 1 to the right. Rise 1, 2, run 1 to the right. Rise 1, 2, run 1 to the right. In order to go backwards, we're going to go ahead and go down 2 and 1 to the left. Down 2 and 1 to the left. And voila, you have your perfect line for this particular linear function. Excellent. Next, we'll do it in blue. Y-intercept in this case is 4. So we go up to the 1, 2, 3, 4 spot on the y-intercept. And then we're going to go down 1, 2, 1, 2, 3 to the right. Down 1, 2, 1, 2, 3 to the right. And then to go backwards, we're going to go up 1, 2, 1, 2, 3 to the left. Up 1, 2, 1, 2, 3 to the left. And voila, we have our perfect line graph for this particular linear function. Always remember, you always run the slope to the right unless going backwards. All right, let's look at some applications of linear functions. There are many applications of linear functions. They are used in everyday life. In order to master the applications of linear functions, it is important that you remember that the f of x or y represents the dependent variable, and that the x represents the independent variable. Keep in mind that time is always independent, as is one's choice. You can choose to work hard or you can choose not to work hard. You can choose to go to the gym or you could choose not to go to the gym. You can choose to care about your studies. You can choose not to care about your studies. Life is always about choice, and choice is independent for everybody. All right, so let's look at an example here. Michael's weekly salary at ABC Car Loft is 0.8% of his weekly sales. So that means you're going to multiply. He's going to earn 0.8% of or times his weekly sales plus $500. The linear function for this situation is S of x equals 0.008x plus 500. Let's investigate that. Remember that the S stands for the salary. That's what we're looking for, the salary, when X, the independent variable, which is sales, is input. And we use 0.008 because 0.8% we have to convert to a decimal. And remember that when we go from percent to decimal, L for 2 places to the left. So that represents Michael's salary S as a linear function of his weekly sales X. So what is the implied domain here? Before you go ahead and say, oh, it's just negative infinity to positive infinity, that can't be. In the real world, we have to think about real world situations. You can't have negative sales, but you could have zero sales. So the implied domain would be from 0 to positive infinity. Now, I know that what you're thinking, there's no way to have infinite number of sales. No, there's not, but that is the implied domain. I can have from 0 sales to as many sales as I can possibly handle. Next, if Michael sells $50,000 in car sales in 1 week, what would his salary be for that particular week? Okay, so let's plug it in. We want to find what the salary of $50,000 in sales would be. So we're replacing our X, our sales, with $50,000. So we've got 0.008 times 50,000 plus 500, and 0.008 times 50,000 is 400 plus the 500 guaranteed salary that you have. So you will earn $900 if you make $50,000 worth of sales. Now let's reverse it. If Michael earned, okay, let's look at that word there. If Michael earned $800 1 week, what was the value of the cars that he sold? So in this case, they gave you the salary. He earned $800. So the salary here in this particular case, the S of X, is $800. And we want to find his sales, which is X. So please be very careful when you're reading these questions, because sometimes they're going to ask you for sales that you need to earn a salary, or sometimes they're going to give you the salary and you need to find the missing sales. So we're going to go ahead and subtract 500 to both sides. Now we've got 300 equals 0.008x. We're going to go ahead and divide 0.008 to both sides. And we're going to use our trusty calculator, and 300 divided by 0.008 will equal $37,500. And that's the amount of sales that Michael made the week that he earned $800 as a salary. Okay, let's go ahead and draw the graph of this function. Well, this isn't going to be as easy as you would think. 0.008, if I wrote it as a fraction, would be 8 thousandths. It's going to be kind of hard to go ahead and manipulate a graph to go up 8 and over 1,000. So what we are going to do is, first of all, we're going to start with our y-intercept, our b. And our y-intercept here is, if x is 0, y is $500. because that's my B. So I'm going to go ahead and plot right here 5. Remember, this y-axis is the salary, and it's in hundreds. So if I make 0 sales, I'm going to at least have a salary of $500. You won't have a job for long if you continue to sell 0, but they will give you some time to learn the ropes. So 0 sales gives you $500. Next, we already have a value. When the sales are $50,000, if you remember up here, we found that the salary was $900. So let's go ahead and plug that in. At 50,000 sales, we have a salary of $900. And now that we have 2 points, if you can remember the slope, how it works, I'm going to go from my first point here, my y-intercept, to my next point, and I can calculate the slope immediately. So I'm literally going up $400 in sales over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10,000 to the right. So I'm going to go up another 1, 2, 3, 400, and then another 10,000 to the right. And there you have it. We have our graph. Pretty cool, right? Now, how much money in car sales does Michael have to earn if he wants his weekly salary to exceed, that means to be greater than $1,800? Well, we're going to go ahead and set up an inequality and solve. So my sales is calculated, or Michael's sales is calculated from 0.008x plus 500, and he wants to know when will that be greater than 1,800. Let's go ahead and solve. We're going to subtract $500 to both sides. And then I've got 0.008x is greater than 1,300. I'm going to go ahead and divide to cancel out multiplication. And x must be greater than, use our trusty calculator here, 1,300 divided by 0.008. It's got to be greater than $162,500 in sales. So if Michael wants to earn more than $1,800 a week, he's got to sell more than $162,500 worth of cars. All right, let's talk about cost function. The easiest kind of cost function is the linear cost function, where C of x equals ax plus b. C of x being my cost, x being my independent variable, my a being the slope, and my b being the y-intercept, or in real life scenario, b is the fixed cost of operating a business. And the a are the costs of manufacturing or making one item. So let's go on, and the a in this case is the slope. So let's say that you own a bike shop which has daily fixed costs of $1,500, and each bike costs $60 to make, sorry about this typo here, to make or manufacture. Write a linear function that expresses the cost of manufacturing X bikes in one day. Well, the cost C of manufacturing X bikes, which is the independent variable, will equal $60 for every X bike that you make plus the $1,500 daily cost. And there you have it. What is the cost of manufacturing 6 bikes in one day? Well, the cost of manufacturing 6 bikes, you're going to go ahead and just plug in the value of 6 in for bikes and calculate. So I've got $360 here plus the $1,500 daily fixed cost. So the cost of manufacturing 6 bikes would be $1,860. Now, let's reverse it. how many bikes can be manufactured for $2,700 in one day? Well, in this case, they're giving you the cost, okay? They're looking for how many bikes. They're looking for X. So in this case, the C of X, the cost, is $2,700. Let's say that's the budget that you can work with. You want to find out how many bikes I can make for that budget. Well, we're going to go ahead and solve for X. Subtract 1,500 to both sides. And you're going to get 1,200 equals 60X. Go ahead and divide 1,200 by 60, and X will equal, trusty calculator if you need, 20. So that means you can make 20 bikes every single day for the cost of $2,700. All right. Next, book value. Book value is the value of an asset such as a building or piece of machinery that a company uses to create its balance sheet. Some companies use what's called straight line depreciation to depreciate, or in other words, decrease the value of their assets by a constant amount each year. Whenever you buy anything, it loses value year by year. That's called depreciation. The amount of depreciation depends upon the useful life of the asset. Suppose that you own a moving company which just purchased new trucks for its drivers at a cost of $26,800 per truck. As a company, you will depreciate the trucks using straight line depreciation over 8 years. That means that the trucks are going to basically work for at least 8 years. So each truck is depreciated by dividing the total cost of $26,800 divided by the useful years of that truck, and that depreciation cost is $3,350. So let's write a linear function that expresses the book value, V, of each truck as a function of its age. Well, the book value, which is going to be V of X, where V is the value of the truck and X is the age of the truck, is going to equal negative $3,350 or negative 3,350X plus the original value of 26,800. So what happened here? Well, what happened here is the value of the truck is 26,800 and it depreciates in value by a value of 3,350 every X years. Now, what is the domain of this function? If you read the actual problem, you know that the truck has a life of 8 years. So I can go from 0 to 8. That is the domain for this particular function because it is a book value and you have 8 years of life for that truck. What is the book value of each truck after 3 years? So let's go ahead and find V of 3 because X is the age of the truck. So I'm going to go ahead and replace the X with 3, which is the age of the truck, plus $26,800. And that is going to give me, if I go ahead and multiply negative 3,350 times 3, that's going to give me negative $10,050 plus the $26,800 value of the truck. And my value after 3 years will equal, go ahead and add 26,800. It will be $16,750. And that will be the value of the truck after 3 years. Now let's pay attention. What will the book value be? Remember, the book value is the actual V, it's the value of each car be $6,700. So when my when is the X and my book value is V. So when will the actual value, 6,700, be accomplished? Well, I'm going to go ahead and solve for x in this particular case because they gave you the value and they're looking for when that value will occur. So we go ahead and plug in our x of, or our value of 6,700. We're going to subtract 26,800 to both sides. And we're going to use our trusty calculator here. Do the math here. 6,700 minus 26,800 will give me a value of negative 20,100, which equals negative 3,350x. Go ahead and divide to cancel out multiplication. And my value x will equal 6 years. So after 6 years of use, the value of the truck will be $6,700. And that is book value. All right, last but not least, drawing a scatter plot or scatter diagram. The data listed below represents the total cholesterol and age in males. A, let's draw a scatter plot, treating age as the independent value. B, let's describe the relation between age and total cholesterol. And C, let's write a linear function for the given data and determine average cholesterol for a 73-year-old man. All right, so let's check it out. When we are creating scatter diagrams or scatter plots, you are going to have some estimating. Okay, that's just part of the game. So the age of 25 gives me a value total cholesterol of 180. So at 25, all right, I have a perfect point here. But there's another person, another human being that is 25 years old that has a cholesterol of 195. So that goes here. 28 years of age will give me 186. So 28 is a little bit before 30, and I got 186, so I would say it's about here. 32 years old gives me 180, so that's about here. 32-year-old also has 197, which is about here. Then a 38-year-old has a total cholesterol of 239. So 38 is about here at 239. You're looking at about right there, roughly. Then we've got a 48-year-old with a total cholesterol of 204. So 48-year-old, that's going to be about 243. You're going to be about right here, roughly. A 51-year-old has a total cholesterol of 243, which, and I'm sorry, the 48-year-old is 204. That's my bad. Pay attention, I apologize. I should practice what I preach. So 48-year-old has a total cholesterol of about 204, which is about here. That's my fault. I apologize. 51-year-old has a total cholesterol of 243, so that would be roughly about here. A 62-year-old has a total cholesterol of 228. So 228 is about here. 62, so you're about right there. And a 65-year-old has a cholesterol of 269. So obviously, it's going to be about right here. You have a lot of different situations. You have different healths. You have different situations for each human. Some are genetics. Sometimes we eat poorly and our cholesterol is higher than it should be. But this is a scatter diagram, which is basically an average of what's going on. So in order for doctors and pharmacists to figure out how much medicine, for example, to give someone, or what the average cholesterol should be, they can go ahead and create an equation, okay? And before they create an equation, they're going to go ahead and make a trend line or a line of best fit. And the way you do that is you usually go ahead and you start with your first value, which is going to be over here. At 25 years of age, you have 180. And you kind of try to go as closely as you can through the middle here to the last point, which in this case is 65 and 269. Okay, so those are what I call my anchor points on the line of best fit. And you can see that there is a positive relationship because as age is increasing, so is the cholesterol level. Okay, so now to get my line of best fit, let's go ahead and get those anchor points, which we went ahead and decided were 25, 180, and 65 and 269. Now this is an average. This is not an exact science when you're doing it by hand. There are computer models and computers that will give you the exact value. But for our intents and purposes, we're going to go ahead and do an average linear function by hand. So if you remember, you can find the slope here, x1, y1, x2, y2. And this is actually going to be a rate of change because we're using units. So we have 269 y2 minus 180, which is y1, over x2 of 65 minus x2 of 25. And we have 269 minus 180. That's going to give us 89 over 65 minus 25 is 40. And for these kinds of real life situations, you can and should go ahead and turn it into a decimal. So my slope here will be 2.225. Okay? Now, what do we do with that? If you remember, we have y equals mx plus b. And we have a lot of values here. We have an x, we have a y, and we have the m, the slope. So all we need to solve for is this b. And how do we do so? We plug in. So the y that we're going to use is 180. The slope that we calculated was 2.225. The x that we're going to use, and we chose to use, is 25. And we are solving for b. So 2.225 times 25 equals 55.625 plus b, and that's equal to 180. I'm going to solve for b by subtracting 55.625 to both sides. And that is going to give me a b of 180 minus 55.625 equals 124.375. That's my b. So remember, when we're writing a linear function, it's y equals mx plus b. The m and the b are the fixed values. The x is independent and the y is dependent on that x. So my function would be y equals m of 2.225 times x, which is my age, will equal, plus my b of 124.375. And then to formalize it into a real life function, f of x will equal 2.225x plus 124.375, where f in this particular case is the total cholesterol and x is the age. All right, so now the last part of this, now that we have the linear function, let's determine the average cholesterol for a 73-year-old man. Well, according to our model, f of 73, the total cholesterol of a 73-year-old man would be 2.225 times 73, which is x, the age, plus 124.375. And let's use our trusty calculator. We got 2.225 times 73. That's going to equal 162.425 plus 124.375. And an average 73-year-old man should have a cholesterol of, when I add these two together, 286.8, according to the model and the information that we were given. And there you have it. Hope you learned a lot. Thank you for watching. Come back anytime. Take care now. Bye-bye.